Alright guys, I just wanted to give us a quick video about the back of today's review since we got a little pushed for time in each of the classes. I have also uploaded the answers to the quiz so you can take a look to make sure you have all the right answers there. And I have uploaded the key to this review also. So I wanted to review, this is called function notation. All of this would be f of x. All of f of x stands for y. If there's a number in this x spot, they're saying, what is y if x is 4? So this means, what is y if x is 4? So we're going to go and look at our graph. When x is 4 is right here, so I'm going to follow it up to the point, to the line, and follow it across, and that comes in at 150. So when x is 4, y is 150, which would be the name of that point right there. We can try it again. This says, what is y when x is 7? So we go to where x is 7, which is between 6 and 8 right there. We go to the line, and then we go across, and it comes in at 200. And so the name of that point is 7,200. 13 here is asking it a little bit a different way. It's saying all of f of x. There's no number in for x. This means y. They're saying, what is x when y is 250? So that means you got to go from the y-axis. Here's your 250 right here, halfway between 200 and 300. Follow it across to the point and bring it down, and it comes down at 10. So when y is 250, x is 10. The name of that point would be 10, 250. 14 asks the same question, except they ask it with the 10. They ask, if x is 10, what is y? So these two are the same question being asked two different ways. So when x is 10, y is 250. Number 15, when x is 16, so I'm going to go where x is 16, I'm going to follow it up to the graph, then follow it across, and I see it comes in at 550. So when x is 16, y is 550. This one, again, there's no number in the x spot. That means we're talking about y. If y is 500, so it's asking you, what is x when y is 500? So I go to where y is 500. I'm going to follow it across until I hit the graph. Then I'm going to come down, and it comes down at 13. So that's function notation. It's a quick way to evaluate. We can either evaluate by looking at the graph, or we can have these kinds of problems where you're given an equation and then asked for specific values. So this says f negative 3. That means, what is y when x is negative 3? So I'm going to take the expression that's given to me, and I'm going to plug in negative 3 for x. So I have 2 times negative 3, which is negative 6, minus 10, which will be negative 16. So f, when x is negative 3, your y is going to equal negative 16. Let's try it again for 18. It says f of 0. That means when x is 0, what is y? So I'm going to, where x is, I'm going to plug in 0. 2 times 0 is 0. Minus 10, I get negative 10, so f of 0 equals negative 10. We're going to plug in 5 this time, or x, because it's in the x spot. 2 times 5 is 10, minus 10 is 0, so f of 5 equals 0. All of these, the only difference is we can't see the graph. The 2x minus 10 is a line. It can be graphed. This represents the point 5, 0. This represents the point 0, -10. And this one represents -3, -16. These are all points on that line. Let's look at a different line. I wanted to look at this one specifically because of the negative out front. What that is saying, it's really saying -1 times x minus 4. When you plug in your number, I'm always recommending you put parentheses around whatever x where you're going to plug in. So if I want to know if x is -5, what is y? So there's the negative, then comes the x, which happens to be -5, and minus 4. -5 is a +5, minus 4 is 1. So f of -5 equals 1. What that means is the point -5, 1 is on the line. This line right here. If I plug in 0, -0 is still just 0, minus 4 is -4. So f of 0 equals -4. And finally, for our function notations, when x is 4, what is y? Plug in 4. I get -4 minus 4, which is -8. So f of 4 equals -8. Alright, so that's our function notation. You can stop this and re-listen to it if you need to. The final section I wanted to go back over was continuous versus discrete. Continuous is whenever you're connected with a line. It doesn't matter how narrow the graph is. It does not have to have arrows on the end of it. It's anytime you've drawn a line in. That is continuous. You're going to use interval notation. Remember, that's your parentheses or your brackets. And when you do that, you name the start and stop values. Okay. So let's look at these guys. So today during class we talked about one way that you can help you see the domain just a little bit better was to draw a box around your graph. I'm going to draw a box around it. I go as wide as it was and as tall as it was to help me see the domain and range. So this, it goes all the way to the left where x is -5, all the way to the right where x is 6. So that is my domain. If I write it as an interval, it starts at -5 and it stops at 6. That's my start and stop. As an inequality, when the name gives it away, it has inequality signs in it. It's from -5 to 6, and we're talking about x values. -5 is going to be less than the x values, and 6 is going to be more than all the x values. So you always use the less than signs. They're equal to because these are equal to points. Our range, we read from the bottom to the top. The very lowest y value, you can see our box went through here at -3, and it went through up here again at 8. So that gives us our range as an interval. That's -3 to 8. Close it. As an inequality, -3, and it ends at 8. We're talking about y values here, and it is equal to on both of those because they are closed points. All right. Function or relation, if I check the vertical line test in this graph passes the vertical line test. There's no x values stacked up over each other, so this is a function. All right, take a look at the second one. We can draw our box again to help us. You don't need the box, don't use it. It's just a tool. Okay. So I can see my very left x value, here's my origin, is at -1, 2, 3. My very right x value is at 2, so that's my domain from -3 to 2. As an inequality, it would look like that. My range, my very lowest range is -2, my very biggest range is 3, so that gives me my range, and as an inequality, It's going to look like that. This graph passes the vertical line test. There's no x's stacked on top of each other, so this is a function. So continuous, anything connected with a line is continuous. Discrete means you can see the individual points. These guys are not connected by a line, they are discrete. The mappings are discrete. The tables are discrete, okay? So that's when we're going to list. Here we can actually list all the individual domains and ranges. So we, remember, use these fancy scrolls for set notation. So the domain is all the x values. So I'm going to look at each point. That x value for that point would be -3. The x value for that point would be -1. Both of these points have the same x value of 1. That tells us right now that's going to be a relation because we stacked up our x values. This x value is 3, and this final x value is 4. We've listed each of the individual x values, and that's our set. Range, we go back and do the same thing for the y's. So I start my set. This y value at this point would be -2. This y value would be -3. This y value would be -1, and this y value will be 2. So we got to list both of them, -1 and 2. I have a y value of 1 and a y value of -3, which I've already listed, so I'm not going to list it again. And finally, our mapping. Our mappings are nice because the one on the left is your domain, the one on your right is your range. So your domain, -3, -1, 2, and 4, and your range, 0, 4, and 7. None of the x values are used more than once. You're allowed to use y values more than once, that's okay, but the x values cannot be, so that makes this a function. Alright, hopefully that helps. I'll see you tomorrow. I'll be here early if you want to come by and ask some extra questions.